Hello class, in today's video we're going to be calculating the 5-figure summary and drawing box plots. The learning intention of today's video is we're going to understand what the 5-figure summary consists of, we're going to learn how to draw a box plot, and lastly we're going to calculate the IQR as well as the range for any given data set. Now, in last lesson, we previously talked about numerical data as well as categorical data. In this particular slide over here, we said there were 4 ways that you could actually illustrate or represent the numerical data graphically. We could either do this using histograms, stem and leaf plots, dot plots, or a box plot. However, there are many disadvantages using the stem and leaf plot and dot plot. We said the reasons why we don't usually see these types of graphs at all, like either in the newspaper or on the internet, is because that these 2 methods are only good at showing discrete data, whereas histograms and box plots, which we generally see more often, they can show both continuous data as well as discrete data. So what we're going to be doing now is we're going to be looking more closely at box plots. In order to draw a box plot, there are a few things that you need to know beforehand so that you could actually draw this correctly. You might know from your understanding from last year, but there are 5 essential things that you need to know so that you can plot this successfully. This includes the minimum value, which is the lowest value, the maximum value, which is the largest value in the data set, the median value, the lower quartile, and the upper quartile. And these 5 things collectively are referred to as the 5-figure summary. So you need to know all of these 5 information so that you can actually draw it. Notice that the mean isn't actually included at all. You don't need to know what the mean is if you wanted to draw a box plot. So where would each of these values lie on the box plot? Well, the minimum value, as I said, was the lowest value. So it's going to be found over here. The lower quartile is going to be like the first part of this rectangle, as you can see over here. So that's going to be where the first quartile or the lower quartile is going to lie. The median is always going to be that line that cuts through in the middle of that rectangle. The third quartile is the end of this rectangle over here, and the maximum value is going to be the other end of the whiskers, in this case over here. This particular slide over here just emphasizes the relationship between the 5-figure summary and the box plot. So when we graphically represent the 5-figure summary, this graph is what we refer to as the box plot, but this is also commonly referred to as the box and whisker plot, since, as you can see over here, these tails or these long lines over here resembles whiskers. And as we said earlier on, the 5-figure summary consists of the minimum, the median, the first quartile, third quartile, and maximum as well. Now, box plots come in all different shapes and sizes, but they still share some similarities, such as all box plots comprises or are made up of 4 segments. So, and it doesn't really matter how long these segments are. Each segment represents 25% of the data set. So I'll show you using an example over here. So let's say that there are 12 data points in total, okay? Now, what this means over here is that 25% of all data values lie between this range over here. So 25% of 12 with 3. So therefore 3 values would lie, let's say here, I'm just showing it over here. Another 3 will lie over here. Another 3 will lie here in this 25%, and another 3 will lie here. So it doesn't really matter how long these segments are. Each of those segments are still worth 25% of data. It just means that the distance between each point is just going to be a bit more scattered or varied or more dispersed in this case. So when we're trying to draw the box plots, what we actually need to do first is, once we've obtained our raw data, notice that our data is generally unorganized. It's not sorted out from smallest to largest. So in order to draw your box plot as well as find the 5-figure summary, we need to order this from smallest to largest. And once we do that, then we can actually find out what is the lower quartile, which is represented by Q1. We can then find out what the median is as well, which is represented by Q2. And the third quartile or the upper quartile is Q3 in this case here. And I've left the definitions of each of these terms in the 5-figure summary down below so that you can refer to. So just some of the key information down on that table is that your lower quartile or your first quartile just marks the position where about 25% is below the data set, and Q3 is where it marks a position where about 75% of the values in the data set is below Q3, and this represents 50%, as you can see. Since this is 25, another over here would therefore be 50%. And all data in total of a box plot would therefore be 100% of a data set. We're now going to be looking at calculating the median for both odd numbered as well as even numbered data sets. So the median refers to the middle value of the data set when arranged in order of size, so from smallest to largest. And I can't really stress this anymore because many students still make this mistake even in year 11, year 12. So it's really important that whenever you do receive a data set, you need to order from smallest to largest, which is shown and represented in this example over here. Now, there are two ways to calculate the median. I just prefer you to use the first method because the data sets that you're going to be looking at are very small. So they only consist of, let's say, between 5 to like 20 numbers, which is relatively small. So this is more effective. So in order to do the first one, what we need to do is we need to cross the numbers from both ends of the data set and progressively move to the center to find the median. So cross out the numbers from either end. So you cross out 13 and 99, and then cross out another pair, so 14 and 71. Do this again, and if you did this, you'll find that your median value, the value that's in the center of your data set, is going to equal to 23. So that's using the first method. Now, there's another way to actually do this, because a great thing about maths is there's more than one way to approach or get an answer, and you could actually use this value, this formula over here. But notice that this formula doesn't give you what the median value is; it tells you what the median position is. So if I was to do this, use this formula, the letter N in this case represents how many values are there in your data set. In this case over here, there's 1, 2, 3, 4, 5, 6, 7. So I'll substitute 7 where N is. So I'll go 7 plus 1 is equal to 8. 8 divided by 2 is equal to 4. So your median position is 4, meaning that if I want to find out your median value, it is in the 4th position. So this is the first value, that's the second, third, fourth. So therefore, this indicates that 23 is going to be your median value, and that's how we obtained it using this method. This method, as I said, only really works very well, and it's a lot more faster if you had data sets that have, let's say, over 20 values. But generally, since we see values that are under 20, we prefer using the first method, and I'll be using the first method throughout the remainder of today's video. We're now going to be looking at examples to finding the median for odd numbered and even numbered data sets. So in the first one over here, the median will always be a value in an odd number data set. So if you look at the first example over here, I've got an odd number data set, and if I was to find out the median using the crossing out method, then as you can see, the median will always be a value in the data set. However, this might not necessarily be the case when you're having a data set that has an even number. So in the following example over here, the median is obtained by finding the value that's halfway between the two innermost numbers in an even number data set. So again, what you do is you just cross out the pairs of numbers, and notice that when you reach the middle, there's actually two numbers over here. In order for you to find out what the median is, you have to find out what number lies halfway between 70 and 72. We know that's 71, but if you had more difficult examples, what you would have to do is you would need to add those two middle numbers together and then divide by 2. So for instance, 70 plus 72 divided by 2, put this into your calculator, you're going to get an answer of 71. So you would generally need to use this formula if you're going to come across more difficult examples. But in this example over here, it's quite straight obvious that the number halfway between 70 and 72 is 71. So no calculations are really required for that. And in this case over here, notice that your median value is 71, and it's not really a part of the data set at all. That's something that you just kind of have to note. And that's one of the differences between an odd number versus an even number data set. So what I'd like you to do now is I'd like you to please pause this video so you can answer these two questions directly inside your exercise book. A little tip is that in order for you guys to actually find the median, make sure you are arranging the values in the data set from smallest to largest before you do the crossing out method. So please pause the video right now and then compare your answers with my answers. All right, the answers that you should get for this question is shown over here. So what you do first is order the actual data set from smallest to largest. I've got an odd number data set over here. So for the first one, it's quite straightforward. Your median value is going to be equal to 4. For the second one, this is what you should get when you order the numbers. Do the crossing out method. Because you've got an even number data set, you need to find out what is the value that's halfway between that. I'm just going to show you full working out. So to find out the median, add those two values together and then divide by 2 to find out the midway number between these two numbers. And if you did this successfully, you should get a median value of 7. So I'm hoping that you guys done this successfully. We're going to be moving on to the next part of today's lesson, which is finding the lower and upper quartile. Now, to find out the low quartile or to find out the upper quartile, they are kind of found in the same way as how you found out the medians. Now remember, when you find out the median, what it does essentially is that it kind of splits the data set into two halves, since the median represents 50% of the data set. And in order for you to find out the lower quartile, what you do is you find out the median of the lower half, and in contrast, to find out the upper quartile, what you need to do is you find out the median of the upper half. So I'll show you in this example over here of how we do that. So first of all, I'm just going to find out what the median is. So in this case over here, because I've got an odd number data set, it's going to be equal to 23 in this case. Now, as I said, when you find the median, this kind of like splits the data into two equal halves. In this case over here, it divides the data set into the lower half and the upper half. And so if I do this, if I divide it, your median, which I've kind of discussed over here, is going to be omitted, meaning it's going to be excluded when you're trying to find out what the lower quartile and the upper quartile. So these are my halves over here, which I've kind of highlighted. Now, once you've separated this into the lower half and upper half, then you can find out what is the lower quartile and the upper quartile. So my lower quartile consists of these three numbers. Notice again that your median is not included at all. And in order to find out the lower quartile, find out what the median is for these three numbers. In this case, it's pretty straight obvious that 14 is going to be the median. So this is your lower quartile, which is represented by the letters Q1. And to find out the upper quartile, these are the three numbers that are contained in the upper half. So therefore, find out the median. Therefore, it's going to be equal to 71. So that's how you solve it for this question. Let's look at one more example, a bit more complex example over here. So this example over here has an even number data set, consists of more numbers as well. So in order to find out what is Q1, Q3, we need to find out what is the median first. So again, cross out the pairs of numbers. And if you do this, you're going to get two numbers in between and just find out what is the middle number between these two numbers. Now notice over here, both of these numbers are 26 and 26. They're the exact same number. The number halfway between these two numbers is pretty much the same number. So it's going to be 26 in this case over here. But I'll still show working out because generally we always want to show full working out. So your median is equal to 26. So your median is going to be over here, okay? So please note where I've marked the median. Remember, we said that the median kind of separates the data into two separate halves and the median will never be included. So if I did this, this is what it will look like. These rectangular parts over here, they've divided the data set into two nice halves. And once I've done this, now I could actually find the median. So again, what I'll do is cross out these two numbers. I want to get two numbers in between. So find out what number is in between 24 and 24. In this case of it, it's still going to be 24. So that is going to be your lower quartile. And to find out the upper quartile, do the exact same thing. You're going to get these two numbers in between. The number between 27 and 28 is going to be 27.5, but I will show full working out for that. And that's how you'd obtain the answer over here. Now, the last thing I want to talk about in today's lesson is measures of spread and what that means. So the measure of spread just refers to how scattered or how varied the data is within the data set. So there are actually three ways you could measure how varied or how dispersed your data values are. This the first way to do this is by calculating the range, which is, and we do this by subtracting the maximum with the minimum. We can do this by calculating the interquartile range, and the interquartile range represents the middle 50% of a data set. And we do that by finding out what our Q3 values and then subtracting it by our Q1. And lastly, another way to actually find out how scattered data are is by finding the standard deviation. And we'll look at this in future lessons. Now, if you look on the example to the right hand side, it reads out which of the following distributions or which of the following box plots has a greater spread. So in this case over here, spread just means how scattered the values are. So the more wider something is, that it's more spread out. So in this case over here, you should agree with me that the first one over here is going to be a lot more varied or a lot more scattered or spread out compared to the other box plot over here. So we're going to be looking at examples of how you could calculate the IQR and range, and then I'll be getting you to answer some textbook questions. So in this case of here, what you want to do is find out the IQR and range by first finding out the 5-figure summary. So in this case of here, the finding out the minimum and maximum is always going to be the easiest. So it's just the smallest and the largest value. So that those values go here. What I need to do next is, in order to find out what Q1 and Q3 is, I need to find out my median value first. So just cross out the numbers from either ends. Because I've got an odd number data set, my median is going to be the central value in the data set, which is going to be 72. And once I do this, I then separate the values into the lower half and then the upper half to find my Q1 and Q3. In this case of here, my Q1, Q3 is the median of each of these halves, which lies in between these highlighted areas that I've shown here. So in this case, find out the values are halfway in between these two. The first one's going to be 64 because the two middlemost numbers is 64. But for the other one, it's going to be halfway between 77 and 81, and that's going to equal to 79 in this case. So that's my value of Q1 and Q3. Once I've calculated the 5-figure summary, calculating the IQR range is going to be really straightforward. So the formula to calculate IQR is Q3 take away Q1. I know that Q3 is equal to 79, Q1 is equal to 64, so substitute the formulas in, and therefore your IQR is going to be equal to 15. To find out the range, it's essentially the biggest value to subtract by the lowest value. So 81 subtract 63, this gives you 18. The last thing I want to talk about is how do we draw box plots, and that should be relatively easy once you've actually found out what the 5-figure summary is. So all we've done is that remember this position over here represents your maximum, so I've put my maximum value over here. This represents your Q3 value, so that's equal to 79. This over here represents your median, which is Q2, which is 72. This value, the start of the rectangle, is your Q1, and this over here, the first part of your box plot, represents your minimum value. So it's going to be relatively easy once you find out the 5-figure summary, but there are a few things that I need you to be mindful of when you're constructing your box plot. First of all, it is very essential that you include this number line over here, and you must include an appropriate scale. So either go up by 2s, 5s, 10s, but don't try to make it such that it goes up by 20 or like 50 or something. Those are inappropriate scales because obviously your box plot will become more compact, and I wouldn't be able to differentiate your minimum with your Q1 in this case, for instance. In addition, a common thing that many students often forget when they're drawing the box plot is labeling their x-axis. Now, in this example over here, because there is no context at all, I don't actually need to include a label. But for instance, if these values over here were reflecting, let's say, test scores, then I need to ensure I put the word or the label down over here, test scores, with the appropriate units as well. So if it's a percentage, I need to include that as well. So the label is only required if it was a worded problem and they're giving you the context of it. If there is no context, then don't include a label whatsoever. What I'd like you to do for the remainder of today's lesson is I only want you to answer these 2 questions over here. However, because you're doing less questions overall, what I need you to do is, once you found out what the 5-figure summary is for each of these, I want you to also please draw a box plot as well for each question. So you're only doing 2 questions, but because you're also drawing, this is going to be somewhat time consuming as well. So please do that for today's lesson. Now, there is one particular question from these 2 questions over here that you probably don't know how to do it because I haven't actually gone into it at all. And that is for questions E and F over here. So you can skip these questions. In our next video, in our next lesson, we're going to be looking at how do we actually identify or calculate outliers within a data set. So don't worry about these two questions over here. We're going to be going through that again next lesson. So don't stress out. Once you've finished answering these two questions over here and the appropriate box plots, I want you to please have a shot at answering this exit ticket over here. There is only about 10 questions in total, so 10 marks. So it will take you about 10 minutes or so not too long. Thank you guys for watching this video today. This is the end of today's video. I'll see you again in the next video. Bye.